Hi everyone, I'm going to show you an example of how to do part 5 on the finance project. So I'm giving an example here of if you had a mortgage that was for $350,000 at 6% for 30 years, and you've already calculated what the payment is going to be, $2,098.42. So when we solve for how many years, if it will take if I add an additional $100 payment. The first thing that I want to do is take that $100 payment and add it to the current payment. So of course we're going to have $2,198.42 as my new payment. And I want to know how long it'll take before I can pay off my mortgage. So we give you two different formulas that you could use to calculate this. I actually prefer the first one because it's the one that we're going to be given on any exam. So what I'd like to do is say the initial amount, the piece of zero is my initial amount. So that's going to be my $350,000 equals my new payment, which is what I just calculated to be $2,198.42. And then I'm going to open up my parenthesis, take 1 minus the 1 plus what is my rate, which is the 6%, as a decimal is 0.06. Of course, divide that by 12. To the power of negative 12 times n. Now n is what we're trying to calculate, so I need to leave that a variable. And then I'm going to divide this by, I'm going to clean up my parentheses a little bit there. I'm going to divide this by the 0.02 over the 12. Okay. So when you do this in your calculator, again, this is all just using algebra. There's multiple ways that you can approach this. The way that I usually approach this is say, let's get rid of this denominator by multiplying both sides by that denominator. So if I multiply by 0.06 over 12 to both sides, that will get rid of that like super complex fraction on the right-hand side. So this is going to eliminate. And in my calculator, I'm going to take 0.06, I'm going to divide it by 12 and multiply it by 350,000. And so mine came out to be a pretty number. Yours may not be, and I'll talk about how to deal with that if that is the case. So I'm going to put the answer on my left-hand side. And I'm going to keep now working on simplifying the right-hand side. On the right-hand side, I'm going to start with what's furthest away from the variable as I start isolating. So I want to undo this times by my payment that I'm making. So I'm going to divide both sides by that. So I'm going to take what I've got in my calculator. By the way, I don't retype what's in the calculator, especially if you had a bunch of continuing decimals or repeating decimals. So I'm going to take this 1750, I'm going to divide it by 2198.42, hit enter, and let's keep working with our algebra. So I've got 0.9602 yada 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 equals the rest of the stuff on the right hand side. Now this outer parenthesis is no longer necessary. It was only necessary there to multiply, if I had to multiply by the 2,198.42 at the end, but we can go ahead and eliminate now that extra parenthesis. And we're going to now work with the algebra. Again, I want to isolate the variable, which is my power, by moving one step at a time. Usually the furthest away is what you're trying to undo. So I'm going to minus the 1, yada, yada. And then what we have on the right-hand side is we still have this negative that we didn't get rid of. So I have a negative and then 1 plus the 0.06 divided by 12, all to the power of negative 12n. At this point, what we want to do is, again, eliminate that negative or subtraction that was in front of the parentheses on the right-hand side. Basically, when I divide both sides by a negative, it's going to end up with both of those being positive. So in my calculator, I want to make sure that what's in my calculator is now positive. So I like to just hit the negative and then my answer. So now it's changed it to a positive value on the left-hand side. So I can't subtract the 1 at this point anymore from what's inside the parenthesis because there's parentheses and the negative 12n is a power to the entire quantity. So what we're going to do at this point is we need to use our logarithm. Because n is a variable and it's in the power, the only way to bring it down and solve for it is to use a log. So we're going to take the log of both sides of my equation. So I get the log of that decimal that I've got sitting in my calculator equals the log of the quantity on the right, 1.06 divided by 12. But now what that does is that changes my power to a multiplication. So it's being multiplied by negative 12. And so it brings it down to multiply when I take the log of both sides. To solve for n at this point, now we can actually use division to isolate the n. So we're going to divide both sides by the quantity, the log quantity, as well as the negative 12. I like to do this actually all at once. If I divide by negative 12, it would get rid of the negative 12 next to the n. And I'm also going to divide by the logarithm of the 1 plus 0.06 divided by 12. So I'm going to do that to both sides of the equation. And this is where we're going to be super careful about how we put this in our calculator. Because my denominator is quite complicated, I actually suggest using extra parentheses around the entire denominator. So I'm going to take in my calculator log of the answer I had, which is the 0.20 right above it, close my parentheses just like I have the parentheses at the end of my numerator, divide by, open up a parenthesis. I'm going to use negative 12. By the way, if you use the minus 12, you might get an error. Make sure you use a negative symbol on your calculator, not the minus. So I have negative 12 multiplied by the log of 1 plus 0.06 divided by 12. Close my parenthesis for the quantity that the log is associated with, and then close the parenthesis again for closing off the denominator. Hit enter. And now I have the value of n. So n is going to take 26.5622 years, right? So that's how many years that it will take. Going back to my project instructions, it does say round it to 1 decimal place. So in this case, I'm going to round it to 26.6 years. For the next step, to find the total number of payments, it just says, and this is where I suggest you actually round it first. Okay, so I'm going to take the 26.6 here. So 26.6, we're going to times that answer by 12 to change it to months, and then round it to an actual whole number. So I take this answer above, multiply it to get a whole number, and I'm going to, even though my calculator says 319.2, I'm going to say that I probably am going to make 319 complete payments. And then you could figure out the total payments. So to figure out the total payments, if I made 319 payments at my $2,198.42, all I need to do, again, take a complete payment, 319, times it by the 2,198.42 to get the total payments, and then subtract as you did in the annuities to find the interest paid. Let me know on the discussion board if you have any other questions or comments.